Hi everybody, Bill Sky, the Assembly Guy, and this is another video on file input and output, and today we're going to talk about appending to a file. What does that mean? That means opening the file, moving to the end of the file, and start writing data to the end. Many times you just need to add data to a file, and that's called appending a file. In previous videos, I showed you how to open the file as creating the file, but the problem with that is that when you do that, if the file already exists, it's just overwritten. So we need to have a way to actually open the file, to be able to write to the file at the end and not disturb any of the data first. So we're going to do this in Windows and Linux. So I don't know, before we get started, it might be a good idea for us to go over what you need to know to really understand what it means to append to a file. So I've got a little drawing here, or a little drawing pad, and what I'm going to do is I'm going to draw out what a file might look like. And this is very simplistic, but let's go ahead and do it anyway. So if I get my mouse working. Okay, so let's say that this is a file on disk. It's not going to be a very straight file, but that's okay. So there's my file on disk, and it's got data in it. It doesn't matter. I don't know. I'm just going to put a bunch of X's in that file. And what actually happens when you open a file? If you remember, the first thing you want to do is you want to open a file. What does it actually mean when you open a file? When you open a file, the operating system contacts the file system and says, hey, I want access to this file. Here's information as to how I want you to open the file. And then the file system comes back and says, yep, file's open, ready to go. But what actually occurs? Well, there's this thing called a seek pointer, or a file pointer. I'll use that term a lot. And the file pointer is a little pointer that keeps track of where you are in the file. So when you first open a file and you have the file is open for read, let's say, the read pointer is at the very beginning of the file. You haven't read anything yet, you've just opened it. So the read pointer is right there. Let's say you go ahead and you read one byte. You read one of the X's. Well, what happens is the read pointer, or the seek pointer, now ends up there. Let's say you read two X's at the same time. Well, now the read pointer is there. And let's say you read one more. Now the read pointer is here. So that is kind of like a little tab, a little bookmark that the file system uses to keep track of where it is. And a lot of times you'll hear that terms like lseek or file pointer or something like that, right? And if you've taken C or C++, if you know how to code with that, you know that you can move that file pointer anywhere you want inside the file, and that is the initial feature that you need to be able to do random file I/O, which will be a follow-on video. And by the way, you can do this anywhere. I can actually move my pointer when the file opens first. My pointer will be there automatically. I can then move all the way to here if I want, and then I can move back to here, or I can then move to the very end, which is what we're going to do to append a file, or I can then move it to here. So that's what we mean by random file access. You can move the read pointer anywhere in the file you'd like. Now, to append stuff to a file, you open the file and then you move the read pointer to the end. So that's the second thing you do to append a file. Move to the end. And then number 3, you start writing. Excuse the penmanship. So you start writing to that file to append it, but you have to move that read pointer. So with that said, let's get started. We're going to do this in Linux and Windows. I recommend you watch both of these videos. Let's get coding. Okay, here we are in Windows, and I have a 64-bit project open. It doesn't matter if you're using my templates or if you created your own. If you're not using my functions at all, it's just fine. So we're going to go ahead and create a file and then append to the file. Now, one thing that we don't have here is, if you remember in my discussion about moving the file pointer, we don't have that file pointer function prototyped here. And these prototypes, if you don't know what these are, go ahead and take a look at my previous file I/O. Actually, I think it was the end of file video on how to prototype them in 64-bit, because this is 64-bit. So we have to prototype the set file pointer function. And as I said earlier, this will move the lseek pointer within the file. And this is really important, especially for random file I/O. And without random file I/O, we wouldn't have databases. So really, really important stuff. So let's go ahead and build this just to make sure I can find the set file pointer. Okay, it looks like it's good. All right. So a couple things we have to do. We have to create, so what I'm going to do is we're going to create a string, write that to the file, and then close the file. Then we're going to reopen it, and we're going to append another string to the end of that. So I'm going to create a variable called string1, and it's just a string to show how to append to a file. And then we have to do some type of a constant that says how big it is. Okay, so that's my first string. Now let's make the second string. And let's do the same thing. Okay. Now a couple of things we're going to need. We're going to need to have a couple of handles. So I'm going to create an output file handle. Now we're going to use define quad here instead of find double because we're on 64-bit. And we're going to have an input file. We also need a total written variable because that's what the call requires. And I'm going to create a total read variable. And we need a file name. And that one must be zero terminated, null terminated. And we'll say file name size equals $ minus file name. And I like to indent those so I kind of show that they belong to there. Okay, so there's our data. I think that's really all we need from the data. So the first string is going to be what we create the file with. The second string is what we're going to append it to the end. And then we need all these things for the create file function, the write file function, the set file pointer function. We need all those. So let's go ahead and just leave those there. That's good, looks good. All right, let's go ahead and build that to make sure everything looks good. Okay, no syntax errors so far. I'm sure it's going to happen. All right, so just as a reminder, if you didn't watch the end of file video for Windows, and you really should have, I would really go back and do that. But if you didn't do that, just as a reminder, when you send arguments to these functions in 64-bit, you don't specify them like you do in 32-bit, where you have the function name, comma, and then all of the arguments using invoke. Instead, we're going to be using call, and these are the registers or the stack locations where we put those arguments. So instead of doing an invoke, we're going to do a call. And remember, an invoke basically is a call after it does this, after it puts that data into the stack or in the appropriate registers. So it's something that Microsoft put together. I've never liked it. I've always liked doing it this way, so it was easy for me. Okay, so number one, we're going to create the file. Let's just say create the file. And remember, there's 3 steps. Open the file. To process the file, write to it in this case, and 3, close the file. And I always like to do this so I don't forget the steps that I have to do. Okay, so in argument number 1 for the create file, and again we're going to say call create file A because that's the function name. So the arguments are going to be, we're going to move into RCX the address of the file name. So that's the first argument. We're going to move into RDX, this 40 million, and that's the access mode of generic write. So the address of the file name, generic write. You just want to create it and write to it. We're going to move to R80, and that was the no share. We're going to move to R9, 0, and this is basically no security. Okay, now here's where we have to specify stack location. So we're going to move a keyword starting at the pointer, RSP plus 32. We want to move a 2H in there, and what that stands for is create always, or always create, depends upon if you're a Yoda fan or not. And then we're going to, let's go ahead and just copy this. And instead of 32, we're going to say 40 and then 48, because each stack location is 8 bytes long. And we're going to put 80 in here. And we did this in the other videos. And this one will be no template used. Basically unused, so we'll just make that into a 0. Okay, and then we call create file A. Now let's go ahead and close the file. Just so I don't forget to do it. It can always be a problem if you forget to close the file. And to close the file, you're going to move into RCX the output file handle. You can dereference it if you like. I always like doing that. Because you're not putting a pointer to it into RCX, you're putting the actual value of the file handle, and then we're going to say call close handle. And stay consistent with our tabs. Okay. And that's closing the file. Now let's go ahead and run this and see if the file actually is created. And we have a little bit of a problem. What does it say the problem is? Immediate operand not allowed. A little irritating because I don't see line numbers here. And I'm not sure why. Okay, so let's turn on line numbers. I don't know why they're gone, so I'll say Tools, Options, and we'll go to Text Editor. Here it is. And let's go to C and C++. Click line numbers, say OK. Yeah, for some reason they're still not showing up. I do not know why. So let's say Tools, Options. Boy, let's go to General and see if there is line numbers here. Let's try this. All languages. Okay, looks like I've got line numbers turned on. There we go. Weird. Okay. So this is saying line 44, we've got a problem. Oh, because I made 49 instead of R9. All right, let's go ahead and run this. Okay, return code is 0. That's good. Let's go find the file. Let's make sure it was created. All right, there's the test file, and it's empty. Great. All right, so that works. Now I'm gonna leave this open kind of over here, so I don't have to do the right-clicking so much. Okay. So the next thing I want to do is I actually want to write the data out to the file. So we didn't process the file yet, so let's do that. So I'm going to move into RCX. File to write to. I'm going to move to RDX. The address of the string that I want to write. I want to move to R8 the S1 length of, this is the length of the data to write. I'm going to move to R9 the address of the variable that's going to say how many I actually wrote. Okay. And like in the EOF, the end of file video, I forgot to do this. There's a fifth argument that really we don't use, but you have to specify it. If you don't, the call dies. So then I'll say call write file. Now we want to make sure that it wrote, so I'm going to compare RAX. Oh, well, no. So I'm going to move into RAX, written, compare RAX with 0, jump if less than or equal to error writing file. So that's going to make sure that we didn't have a problem writing the file. So let's go ahead and put that in there. And you should really put something in there like a print or something like that. Okay. And then after we close, we'll go ahead and say jumped and it all. And we're closing the file. Now what we should get is we should get a file that actually has some data in it. Let's go ahead and start without debugging. Okay, well, we got an error of some type. Let's take a look at what we've got here. So we put the output file. Now, did we save the output file handle? Nope, we never saved the output file handle. Oops. So what we're going to do is we're going to compare RAX with 0. We want to make sure it opened correctly. Jump is less than or equal to error opening file. So what happened there was it tried to write to a file handle that we never set up, and that's what we're going to do here. Otherwise, move up. Here's what we're doing it right here. There we go. If an error. Otherwise, save the file handle. Okay, can't believe I forgot that. Now we have to create a label called error opening file down here. Okay, no problem. Oops. Keep forgetting if I'm not on Mac or Windows. Okay, no up and jump. Okay. Let's try to build it. All right, let's debug it start without debugging. We still have a problem. We still have a negative return code, so let's try to figure out what we got here. So we create the file. The file name, we've got 40 million, we've got 0h. Let's make sure we did this right. Yep, that looks right. We have 0h and R8, 0h and R9. We've got the 2, the 80, and the 0, and the 32, 40, and 48. Okay, that looks good. Let's debug this. Let's make sure we find out exactly where the problem is occurring. Okay, so let's try to create the file. It seems to have worked. There's an A4 in RAX, so that looks good. Now we're moving the output file handle in RCX, the string, the address of the string into RDX. We're moving S1 length of. Oh, I think that might be, yeah, this is the problem, or this might be a problem down here. We need to make that, because it's a constant, right? S1 length of is a constant. So we have to do it without the square brackets around it. And I wholeheartedly believe that that's the problem, but I've been fooled before. So debug, start without debugging. There we go, 0 return code. And we go back over to here, we double click on test file, and there's our data. So we got data in there. So we have a file with some data in it. Okay. So now, let's append to the file. And just like with creating the file, we have to open it, process it, and close it. So I'm just going to copy all of this code from the open, process, and close. I'm going to copy that all there. Now instead of appending the file, we're going to open the file for input and output. And it's pretty much the same. The difference here is that we're going to put a 10 instead of a 40 million. So this means everything. Input and output. Okay. Now we also, R8 and R9 are 0, but now we also want to say 3H, and this is open an existing file. And 80 and 0 are fine. And then it'll open it up. All right, great. I'll save and build it. We're going to just stick with the output file handle. It's just a name. Okay, so now we want to process it. So to process the file, there's two things we have to do. If you remember my little graphic that I drew, we have to position the LC pointer to the end of the file. And then the second thing we need to do is write to the file. Now we're going to write string 2, so let's go ahead and change all this to string 2. And really, that's all you need to do for the write. You pretty much have the write done. So now we have to move the LC pointer. And to do that, we're going to use the set file pointer function that we prototyped above. So I'm going to move into RCX. The output file handle. I'm going to move into RDX, 0. Now this is where it gets a little bit confusing. 0 is the lower number, lower 64 bits, the lower 64 bits of how far to move. What's he talking about? Well, let's continue. I'm going to move into R8, 0. This is the upper 64 bits of how far to move. Oh, what's he talking about? Well, one last thing before I answer that question. I'm going to move to R9, 2H. 0 equals the beginning. 1 equals current position. 2 equals the end. Okay, so let's talk about this. I think it's pretty understandable that RCX will contain the file handle where you want to move the pointer. But what is this RDX and R8 thing? What are those two arguments? The position set file pointer function, it takes those two values, appends them as one big long value. And the reason that it does that is because files in 64-bit can get humongous, 80 gigabytes. Just huge, xenobytes I think it is. And so to be able to accomplish that, they have an upper 64 bits and they have a lower 64 bits because you can't really send an argument that's 128 bits. So it splits them in two and sends them as two separate things. So what this means is that because the lower is 0 and the upper is 0, what that means is it means move 0 bytes from the end of the file. So what that does is it takes the file pointer and moves it all the way to the end of the file, or maybe this to the end of the file, without having to read any data in there in between. And then it calls set file pointer. Let's stay consistent. So now if you wanted to overwrite the beginning of the file, you could have changed this to a 0, and that means start at the beginning. Or if you leave this, or if you make this a 1, that means wherever your read pointer, your lseek pointer is located, it'll just start writing in that location. So, but this is pretty common to do this for appending to a file. Okay, let's go ahead and save and build this. And let's just run it. Now remember, when we look at this file before we run the appended version, it just has a string to show how to append a file. Let's go ahead and run it now. And now let's look at the value. And you can see the text that was appended to the end. So when we opened the file for input and output, the pointer was pointing to the A. We said reposition it 0 bytes from the end, which put it right after the E. And then we wrote the comma, and this is the continuation string to the file, and then we closed it. Let's make sure we closed it. Yep, we did close it. Okay, so that is an example of appending to a file in Windows. The next videos we're going to do, the last ones on File I/O, is really advanced File I/O, random access, being able to move all around, but that set file pointer thing is paramount to doing that, is that you have to know how to move that file pointer, that LC pointer around the file. Hope to see you in our next video.